Hello participants, we will be taking tutorial class 4 on the topic of measurement of irrigation water, and we will be discussing about the pumps, the problem which we dealt with in theory class. We discussed about pumps. So, we will go in detail and you will have practice to learn and on by solving the problems on pumps and as well as measurement of irrigation water. So, let us come to those directly to the problems. Water discharging through a tube well passes through a rectangular weir of 45 centimeter long, means its the crest width length is 45 centimeter and water over the crest is of 12 centimeter, that is the head. We are required to determine discharge under following condition: with no end contraction, with one end contraction, with two end contraction. So, effective length of the weir is one is without reducing the length, another one is reducing the length. So, there is a specific formula which is to be taken care while we are using one end or two end contraction. Now, if the discharge of the same rectangular weir with no end contraction, this is the thing which is given, means the discharge which we are getting from the case 1, it passes through a 90-degree V notch. What will be the head over a weir? So, this is the question which is given to us, that what will be the head of water over the crest of a triangular 90-degree triangular weir. So, it is a very simple thing, it is given, length is given, length of the weir crest is 45 centimeter, head over the rectangular weir is 12 centimeter. So, if a very standard Francis formula is available when this weir has no end contraction, the discharge Q is given by 0.0184 into L into H to the power 3 by 2. L is known to us, H is known to us, it is simply using these values and one can get the discharge from a weir. So, this discharge is coming at 34.42 liter per second when we have got no end contraction. When one end contraction means length is reduced. Now, when one end contraction means contraction is there. So, this effective length is reduced by L minus 0.1 h. So, 0.1 h will be reduced from the length and then it will be used. So, this is the formula. So, effective length is reduced and then remaining formula will remain same. So, discharge Q is 0.0184 into L minus 0.1 h into h to the power 3 by 2. So, just simply we are substituting, because L is known to us, that is 45 centimeter, and h is known to us, that is 12 centimeter, and we are substituting the value and we get reduced discharge as compared to this one, because effective length is reduced. Now, when two end contraction means both the side, this means the contraction is there. So, effective length is reduced by L minus 0.2 h, and then substituting the value we get the total discharge Q equal to 32.58 liter per second. Now, discharge from 90 degree V notch is same as discharge from no end contraction. So, discharge from 90 degree V notch is given by Q equal to 0.0138 s to the power 5 by 2. This is also a Francis formula, where Q is expressed in liter per second, h is in centimeter. So, this expression we are just simply substituting the values, that h can be written as Q by 0.0138 in this into the power 2 by 5, and so we are getting the value is 22.84 centimeter. So, this is the desired answer. This is the desired answer for the flow through 90 degree V notch. Now, in another question, this is given. This question is basically we want to know the how much what should be the capacity of the centrifugal pump. A farmer has land holding of 5 hectare with cropping pattern given in the table. So, what is the cropping pattern? He is growing wheat, cotton, vegetable and mustard, and then total area in this question is 5 hectare. So, this 5 hectare is distributed in different crops, and each crop requires certain depth of irrigation, which is given corresponding to each crop. So, these are the values of depth of irrigation, and then irrigation interval, that a rotation period, it is given as 12 days for wheat, 20 days for cotton, vegetable 10 days and mustard 40 days. And daily operating time of the pump is means a different days for each day. So, for wheat crop it requires 10 days daily, then 10 days, means for all these crop it requires 10 hours each day. So, these are the data available, and we want to know what is the capacity of the pump that he of a centrifugal pump, the farmer wants to have that pump. So, the discharge capacity of the pump can be given by area into depth of irrigation multiplied by the means the rotation period or irrigation interval multiplied by the number of hours per day operation, and this is calculated in terms of liter per second. So, where area is in hectare, depth of y is the depth of irrigation in centimeter, and then the irrigation interval or rotation is in days, and T the time of operation, daily operation of the pump in hours. So, simply we are substituting the value, because 2 hectare is given, depth of irrigation 7.5 centimeter. So, these means for each crop these values these proportions have been calculated, and we are getting these values calculated here. These data are available from this 0.015. So, all that it is calculated, and then we are getting the discharge capacity of the pump should be 5.72 liter per second. So, this is the discharge capacity of the pump. So, this means this theory part of this question, it was discussed in the theory class, and we have also solved problems. So, how these information it can be utilized for deciding the capacity of the pump. A third question, here it is given, a pump lifts water of 1 lakh liter per hour. So, this is the discharge of the pump against a total head of 25 meters. So, this is the head requirement it is given. Now, we are required to compute water horsepower if the pump efficiency is 75%. Okay. What will be the size of prime mover to operate this pump if direct drive electric motor having an efficiency of 80% is used. So, this is the another data available, that efficiency of the motor is given. Compute the cost of electrical energy in a month of 31 days, and if the pump is operated 10 hours daily, and the cost of electrical energy is per unit is rupees 4.5. So, 4 rupees 50 paisa per unit is being charged. Pump is operating 31 days, and each day the pump is operated for 10 hours. Efficiency of motor is 80%, efficiency of pump is 75%. The pump is operating at a total head of 25 meter, and at this 25 meter it is delivering discharge of 1 lakh liter per hour. So, these data are available, which I have told you here. These data one can see that whatever I have told, that this information is available. So, water horsepower is given by discharge in liter per second multiplied by total head in meter divided by 76. This is the WHP formula. So, we are just simply substituting. The discharge is given this week are means this is we are converting this because it is in liter per second. So, 10 is to power 5 divided by 60 multiplied by 60. So, this is converted to liter per second. So, then 25 meter is given as the head. So, and so this will give the WHP substituting these values. So, this is coming as 9.14 as water horsepower. Now, shaft horsepower is WHP divided by pump efficiency. So, pump efficiency is given as 75% and WHP is 9.14. So, 9.14 divided by 0.75. So, this is your shaft horsepower, that is 12.19. It is a simple calculation, we are dividing, and since it is given the pump is direct driven, the shaft horsepower is the same as brake horsepower. So, there is not it is a very simple that because it is there is no loss. So, the horsepower, brake horsepower will be same as the shaft horsepower because it is a direct driven. So, now we want to know what is the power input to electric motor. So, power input to the electric motor in terms of kilowatt hour, kilowatt, we can get that brake horsepower multiplied by 0.746 divided by motor efficiency. So, we will get already we have got the value of brake horsepower is same as the shaft horsepower multiplied by 0.746 divided by 0.8. So, this is the power requirement to operate the motor. So, total energy consumption per month will be power input to the motor. So, this is 11 kilowatt and time of operation of the pump, this data is available to us. So, the time of operation, daily time of operation is 10 hours, operation period is 31 days. So, we are getting the total energy consumption as 3524.7 kilowatt hour. Now, we have been given the this electrical charges, the charge is 4 rupees 50 paisa. So, we will get, so we will be getting the value that is 3524.7 multiplied by 4 rupees 50 paisa. So, this will be the electrical charges. So, this particular part. So, normally when we are interested to know that how the electrical units are converted, and then whatever is the appropriate charges that can be obtained. Question 4 is this is relevant to measurement of irrigation water, which is given as a venturimeter is used to measure water flow rate in micro irrigation system. Now, pressure difference across the venturimeter means there are two manometer which are connected, one is at the inlet end, that is your converging section, one is at the throat section. So, these two places these manometer we are getting the values of pressure, and that pressure difference between the means at converging section and at the throat section, this is given as 8 meter, this is equivalent to 8 meter. Pipe diameter is 19 centimeter, the throat diameter is 10 centimeter. In throat there is a constriction, because of this constriction the pressure difference will take place. So, this diameter is given. Coefficient of discharge for venturimeter is 0.96. We are required to find out the flow rate in the pipe where this venturimeter is fitted. We are using venturimeter to monitor the discharge through the pipeline having these dimensions. So, pipe diameter is given 19 centimeter, pressure head difference across these two places in the venturimeter is 8 meter, and then the diameter of the throat section, that is your 10 centimeter, coefficient of discharge is 0.96. So, those are the data, and it is a very straightforward question. Q the discharge through a pipeline can be given by Q equal to C D into A 1 into A 2 square root 2 G H then square root A 1 square minus A 2 square. Now, A 1 refers to the area of cross section of pipe, A 2 refers to the area of cross section of the throat section, H refers to the pressure head difference. So, we need to, for these two diameters we need to find out the area. So, area of the pipe is obtained as 2.84 into 10 to the power minus 2 square meter. A 2 for 10 centimeter diameter we are getting 7.85 into 10 to the power minus 3 square meter, and having got this value we need to just simply substitute these values. We are getting the value as 0.095 cubic meter per second, which can be written as in the liter per second, that is 95 liter per second. Now, so this way we will find out the we got the discharge through pipeline. Question 5, it is given here, actual velocity of a liquid passing through a 7 centimeter diameter orifice meter. This is orifice meter, orifice plate is fitted and it has fitted in a open tank which is receiving water as 6 meter per second velocity. The velocity of flow is 6 meter per second. Okay. If the velocity coefficient and discharge coefficient, so velocity coefficient C V is given as 0.91 and discharge coefficient for this orifice is 0.67. So, we are required to find out the actual discharge through the orifice. So, diameter of orifice is known to us, velocity of flow is known to us, C D that is the coefficient of discharge is known to us, that is 0.67 and coefficient of velocity of this orifice is 0.91. So, velocity of flow through orifice is given by V equal to C V into, that is the coefficient of velocity multiplied by root 2 G H. So, this is velocity is known to us. From using this particular expression, one can know what is the height from the center of the orifice to the water level. So, one can know what is the height of water from the center of orifice. So, H is calculated. Now, at point 2 we are required to find out actual discharge in orifice. So, actual discharge in the orifice is given by coefficient of discharge multiplied by the cross sectional area. So, into root 2 G H. So, root 2 G H is the velocity component and this is the coefficient of discharge component. So, C D is known to us, that is 0.67. Area is we have to get the area calculated for this diameter. So, area is given by pi by 4 into 0.07 square, that is pi by 4 d square. So, this is the area and the root 2 G S is the velocity component. So, once we are calculating this value, actual discharge comes out to 0.017 cubic meter per second, which is equal to 17 liter per second. So, this is the answer for the question 5, where we were required to determine the discharge from orifice. Now, in question 6 we are given a centrifugal pump which is running at a speed of 1800 rpm at its best efficiency point and discharged 50 liter per second. So, rpm is known to us and then the discharge is known to us, and then we are given total head of 30 meter. We are required to determine the specific speed of the pump. So, the sixth problem is related to pump, calculation of a specific speed. This relates to pumps. Now, so the pump which is given, it has a speed 1800 rpm, discharge 50 liter per second, which is equivalent to 0.05 cubic meter per second and head at 30 meter. So, it is a straightforward problem where we are substituting the values in a specific speed formula. So, a specific speed formula is given by n s equal to n into q to the power half divided by s to the power 3 by 4. So, we are substituting value n is given from the question, that is 1800, and then discharge is given at 0.05 cubic meter per second and then head in the pump is 30 meter. So, head measured is 30 meter. So, just simply we are substituting the value and we get a specific speed of this pump as 32 rpm. So, this is the answer. So, we given pump a given one speed, but a specific speed of the pump can be a specific value which will be which will depend upon the speed of the pump, it will depend upon the discharge of the pump, it will depend upon the operating head of the pump. So, this is a important index which is used to for when we are selecting a pump. Now, question 7 is also question 7 is this relates to also a pump. Here we are required to determine practical suction lift for a pump having discharge of 38 liter per second. Water temperature is 20 degrees Celsius, at which saturated vapor pressure is 0.24 meter. So, it has a discharge 38 liter per second and saturated vapor pressure is 0.24. Total friction loss in 10 centimeter dia suction pipe and fitting is 1.7 meter. So, this data is also available, that what is the frictional loss which takes place in the pipeline, and frictional loss in the pipeline plus fittings. So, this is equal to 1.7 meter. The pump operates at the altitude of 300 meter above mean sea level. So, here one important point it has come, it is above 300 meter, means it is operating at 300 meter above mean sea level. Now, use altitude reduction for atmospheric pressure at a surface for a sea level of 0.36 meter. So, when we are going above sea level, the reduction in the atmospheric pressure, that particular value is also known, that is a 0.36 meter. Net positive suction head of the pump, which is normally supplied by the manufacturer, is 4.7 meter, and we are considering in the question it is given not means the factor of safety is given as 0.6 meter. So, these are the data available to us. We are required to find out the maximum practical suction lift. So, I am just repeating the data. We have been given pump discharge 38 liter per second, which is equivalent to 0.05 cubic meter per second. We are given vapor pressure value as 0.24, head loss due to friction in the pipeline and fitting is 1.7 meter. We have been given net positive suction head, that is NPSH, is 4.7 meter. We have been given the factor of safety as 0.6 meter, and since the pump we are considering 300 meter this particular. So, this elevation altitude is causing. So, this will reduce the this your suction. So, this altitude reduction is 0.36 meter. So, this value, these values are given. Now, we will be obtaining the value. So, here it is given that atmospheric pressure at water surface is 1 kg per square centimeter, which is equivalent to 10.33 meter, and this atmospheric pressure at 300 meter means we are going above sea level. So, this is to be reduced by 0.36 meter. So, this value is coming as 9.97 meter. So, maximum practical suction lift for a pump is given by the formula, that is H s equal to H A minus H f. What is H A? H A is given to us, that is 9.97. H f is given, that is the head loss to friction, that is H f is given as 1.7 meter. Saturated vapor pressure is 0.24 meter. NPSH is 4.7 meter and factor of safety is 0.6 meters. Simply we need to substitute the value to get maximum practical suction lift of this pump. So, we are just substituting this value, that H s equal to 9.97 minus 1.7 minus 0.24 minus 4.7 minus 0.6 meter. So, this is equal to 2.73 meter. So, this is my answer. So, this particular question was also relating to this pump, and these parameters are important while we are selecting pump for installation in a given set of condition. So, this to solve these problems, you may refer books by Rayleigh James, you may refer book by A. M. Michael, that is Irrigation Theory and Practice by Michael, and then S. D. Kheper and A. M. Michael, S. K. Sondhi, they have written a book which is on water wells and pumps. This can be also used. You can refer a book, Land and Water Management Engineering by Vivian Murthy. Let me summarize this thing. We solved this tutorial by considering the numerical problems on measurement of irrigation water and irrigation pumps. Now, forthcoming lecture we will discuss about irrigation methods. Thank you very much. Good day.